Okay guys, so let's proceed with the second problem for statically indeterminate members. So basahin natin, a horizontal bar of negligible mass hinge at point A as shown in the figure and is assumed as rigid. This is supported by a bronze rod 2 meter long and a steel rod 1 meter long. Using the following data, compute the stress in each rod. For steel, area is equals to 600 mm squared. And the modulus of elasticity is 200 gigapascal. The proportional limit is 240 megapascal. And for bronze, that area is equals to 300 mm squared. The modulus of elasticity is 83 gigapascal. And the proportional limit is 140 megapascal. Compute the stress in each rod. Okay guys, so for this problem, so meron nga daw tayong rod dito. So meron ang rod which is hinge at point A. So again, here, meron kang reaction. But then again, hindi naman natin siya kakailanganin. And at this point, 0.6 meter away from point A, meron kang steel rod with the following properties. So isulat natin yung kanyang mga given. So dito na lang. So the area of the steel rod is 600 mm squared. 100 mm squared. And the modulus of elasticity. So ito guys, kung mapapansin nyo, pare-pareho lang naman yung value niya. So pakitandaan na lang ako ng mga value ng modulus of elasticity for steel, bronze, and aluminum. So just in case na hindi ibigay, at least alam nyo. Okay? And the proportional limit, so later on, i-discuss ko kung para saan ba itong proportional limit na ito. So ito naman is parang kapareho lang ng mga boundary condition na binibigay dun sa mga previous problem. So the boundary or the proportional limit is 240 megapascal. Okay, so for the bronze, the area of the steel rod, the area of the bronze rod is equals to 300 mm squared. Where E is equivalent to 83 gigapascal. And the proportional limit is 140 megapascal. So find or compute the stress in each rod. So again, ano nga yung first step natin? So diba, gagawa tayo ng free body diagram in order to make an equation for the unknowns. Okay? So guys, kapag pinutol mo tong steel rod at saka yung bronze rod, ito yung makikita mo. So palitan ko lang yung kulay ng marker. Gawin natin green. So diba, pag pinutol mo siya, ganyan, ito yung lalabas sa'yo. So meron ka ditong P steel or the force acting at the steel rod, and here you have P bronze. So dito meron kang 50 kN. Okay? And at this point, sabi ko nga, meron ka dito na reaction, but then again, hindi naman natin gagamitin. So ipakita lang natin. So since yan, meron kang RAV and RAH. Okay, so ayan, ito yung mga forces. So ayan ko lang. I-bold ko lang yung mga force na yan para kita. Pataas. Pataas. Ito na lang yung gagamitin ng free body diagram ha. Hindi na ako gagawa ng isa pa. Since limited nga lang yung space natin. Okay. And dito meron kang pababa. Okay, so from this, gagawa tayo ng equation. So ano yung equation na magagawa natin from this free body diagram? So pwede tayo mag-summation ng moment at point A. So again, assuming that all counterclockwise moment as positive, when we take summation of moment at point A, the equation will be equals to, so we have 0.6, so distance times the 4 ng P steel plus, so 1 plus 0.6, so we have 1.6, so multiply by the force na P bronze, and then minus 50 kasi clockwise siya, so i-transpose ko sa kabila to make it positive, so equals to 50 multiply by the distance of, so 0.6 plus 0.8, 1.4 plus 1, so 2.4. Okay, so this will be our equation number 1. Okay, so saan natin makukuha yung sunod na equation? Okay, so kapag nag-summation ng forces horizontal tayo, wala naman tayong makukuha, yung RAH lang, hindi naman natin kailangan. Kapag summation ng forces vertical, may relate natin yung RAB, which is hindi rin naman natin kailangan. So again, kapag wala anong pagkuhanan ng isa pang equation, doon papasok yung iyong delta o yung iyong magiging deformation. So again, so yung system, i-assume natin o sasabihin natin na magkakaroon siya ng deformation based on the applied load na 50 kN. So if that is the case, so mangyayari dito sa ating steel rod magiging ganito. So because of this 50 kN, ang mangyayari dito, again, ano nga sabi? I-exage mo yung drawing. Ayan. So because of that 50 kN, nagkaroon tayo ng deformation. Bumaba yung iyong steel, yung iyong horizontal bar. Okay? So pagbaba niyang ganyan, so ito na yung 50. And then ito, nag-elongate. Okay? Bumaba yung iyong steel bar, saka yung iyong bronze bar or the rod. So, therefore, ito, I will name this as my delta or the deformation for the steel. And this one as the deformation in the bronze part. Okay, so siguro nagkaka-idea na kung paano makukuha yung sunod na equation. So, magkakaroon tayo ng ratio and proportion para mapalabas natin yung isa pang equation. Ano? So, by ratio and proportion or by R and P, ano yung magbubuo nating equation? So, we have deformation of the steel over 0.6 is equals to the deformation of the bronze over 1.6. And we all know that delta, so ano yung formula natin ulit? So that is PL all over AE. So with that, we have here P steel. What is the length of the steel rod? So ayan, given naman sa figure, that is 1 meter long. So multiply na lang natin ng 1 over, so PLAE. So what is the area? So given naman as 600. And we have modulus of elasticity na 200 gigapascal. Okay ha? So hindi na ako nagta-times 10 to the 3, hindi ko na inaalam yung unit kasi yung equation natin ganito. Equals. So maakancel lahat ng conversion na ginawa natin. So basta magkapareho lang yung mga units sa magkabilang side kahit hindi sila pare-pareho ng naka-meter, naka-mm. Okay lang yun kasi maakancel nga ulit kahit i-convert natin. Ano? Okay, so PLAE, so multiply. So ito meron ka pang 0.6. Okay, so that is equals to dun sa P bronze. What is the length of the bronze rod? So we have 2 meter over area na 300 times 83 Pascal and then 1.6. Okay guys, so ito, ang gawin ko, i-transpose ko sa kabila. So mangyayari lang, magiging minus to kasi nilipat ko sa kabila, and then magiging equals to 0. So this will be my equation number 2. Okay, so pindutin lang ulit natin sa calcu. So pwede ko naman mag-elimination or mag-equation tayo. To equation to unknown. So gamitin natin yung ating mas upgraded na calcu para mahanap yung mga unknown. Okay? Okay guys, so pindutin natin. So we have 0.6 plus 1.6 and then 50 times 2.4 and 1 divided by 600 divided by 200 divided by 0.6. Negative 2 divided by 300 divided by 83 divided by 1.6 and then 0. Okay, so the P in steel is equals to 115.0895 kilonewton. And dun sa isa, for the bronze, that is equivalent to 31.8414 kilonewton. So with that values, we can now solve for the stress in each rod. So let's start with the stress in steel. So again, ang walang kamatayang P over A for steel. So salpak mo lang to, si 115.0895 kilonewton over the area, which is given din naman to 600 millimeter squared. So ito guys, multiply na lang natin ng 1,000 to make it in megapascal, okay? The stress in steel is equals to 115.0895 times 1,000 divided by 600. The answer here is 191.8158 megapascal. And for the bronze, ganun lang din naman. P over A of the bronze. So sabay-sabay natin pindutin. So we have 31.8414. So times 10 to the 3. 1,000 divided by the area for the bronze rod, which is equals to 300. So the answer will be equals to 106.138 megapascal. Okay guys, so as you can see here, ito is less than dun sa ating proportional limit. That is less than 240 megapascal. And yung for bronze, so ang kanyang limit is hanggang 140. So again, this is also less than do sa proportional limit. Okay, so ano ba yung mangyayari kapag lumampas yung isa dyan? Ano? Okay, so if the steel stress, for example, had exceeded the proportional limit, kapag lumampas ka doon, the results would not have been valid and a redesign would be required. Ibig sabihin, hindi siya pwedeng mangyari kasi lalampas ka sa proportional limit. Ano nga yung doon sa Hooke's law natin, doon sa stress and strain diagram? Ano yung kasunod doon sa proportional limit? Kapag lumampas ka doon, papata ka doon sa elastic limit. Tama ba? Ano? So, yung proportional limit na given dyan, yan yung maximum dun sa ating graph. So, ibang condition na kapag yung elastic limit na tayo nag-lie. Okay? So, kapag ganyan na nangyari, pag lumampas ka dun sa proportional limit, kailangan mo siyang i-redesign. So, paano ba tayo magre-redesign? So, perhaps the simplest redesign would be to increase the length of the steel rod, pahabain mo yung length, or baguhin mo yung kanyang cross-sectional area. Okay? Thus, making it less rigid. So, take note, it may be noted here that generally, the most rigid parts of an indeterminate structure carry the most load. And This fundamental principle in the theory of indeterminate structure is known as the principle of rigidities. Okay guys, so ayan. So our final answer here is this 2. So for steel, 191.8158 megapascal, and for our bronze, that would be 106.138 megapascal. Okay guys, so let's proceed with the next problem. Okay guys, so let's proceed with the third problem for statically indeterminate. So a copper rod is inserted into hollow aluminum cylinder. So meron ka daw dito. So ito is aluminum, ano? So hollowed siya. So sa loob niyan, meron kang copper rod. So the copper rod projects 0.005 inches as shown in the figure. So kung mapapansin nyo, yung ating copper rod, mas mahaba siya compared do sa aluminum cylinder. So yan yung gustong sabihin ng copper rod. Sabi na project daw siya ng 0.005. So itong pagitan ng iyong aluminum at saka copper, so yung nakalawit na yan, so that is 0.005. So anong tanong? What maximum load P may be applied to the bearing plate? So again, meron kang bearing plate dito, but kagaya nga nung diniscuss ko sa inyo before, yung bearing plate, sinasabi niyan na yung load P will cause a deformation hanggang dun sa aluminum cylinder. Ibig sabihin, magkakaroon siya ng deformation hanggang dito. So let's just say na yan, bababa siya hanggang dito. Kasi ito yung iyong initial position. But because of this load P, bababa siya hanggang dito. Okay? So I hope na visualize yung mangyayari do sa ating system. So use the following data for the following. For copper, we have an area of 2 inches squared. The modulus of elasticity as 17 times 10 to the 6 psi. And the allowable stress as 20 ksi. So for aluminum, area is 3 inches squared. And E, the modulus of elasticity is 10 times 10 to the 6. And allowable stress is 10 ksi. Okay, so ayun nga. So ang gawin natin, i-drawing muna natin siya. So paharapin natin itong drawing na to. So kung mapapansin nyo to, itong shaded, ihaharap natin siya sa atin para mas madali nyong makita. So ano ba magiging itsura niyan? Okay, so i-project lang natin. Ayan. So ito, meron ka ditong aluminum cylinder. So when we say cylinder, ayan siya. So yung cylinder mo butas sa gitna. So sa gitnang yan, may naka-insert na copper rod. Kung saan yung copper rod mo, mas mahaba siya ng 0.005 inches. So exage lang natin yung drawing. Ayan. Okay. So dito, 'di ba may bearing plate nga siya. So dun sa bearing plate pa lang, parang pinapahatid na niya na bababa ako hanggang dun sa mayroong aluminum cylinder. This is your load P. Okay. So ang pinapahanap again sa problem is itong value nung P. What is the maximum value of P that may be applied? Considering the following condition. Okay. So, ang gawin na lang natin, ito yung, sabi nga, ito naka-shade yung iyong aluminum. Aha. So, labelan lang natin. So, again, ito ay 0. So ito naka-project na to is 0.005 inches. Okay, so hindi lang pinakita sa drawing but ang height ng ating aluminum cylinder is, ulit ko lang dito. So ito is equivalent to 10 inches. Okay? So lagay natin dito. So that is 10 inches. Okay, so gaya nga nasabi ko kanina, from here, ayan, ito yung magiging initial position mo. So denote natin ng IP. And after applying this load, ang mangyayari, magkakaroon siya ng deformation hanggang dito. So this will be the final position. Okay? Okay guys, so kung magkakaroon ka ng section dito, kung puputulin natin siya dito, ayan. So nag-section tayo. So mangyayari dito, burahin natin yung lower portion. Okay, so pinutol natin siya again. Ayan. So gagawa tayo ng free body diagram. So first, yung copper rod mo, magke-carry siya ng internal load. So again, if this is pababa, therefore, etong force mo dito will be upward to counteract that downward force. So this will be for P copper. Okay? And then, for the aluminum, since ano naman siya, symmetric and concentric naman, nasa gitna. So, ang copper mo, meron ka rin dito na upward force. Sa gitna lang din siya. So, this will be our P of aluminum. Again, if you're going to apply the equilibrium equation, so ang equation na produce natin, when we take summation ng forces ng y equals to 0, assuming upward forces as positive, so what will be the equation? So we will have P copper plus P ng aluminum will be equals dun sa P. So I will name this as my equation number 1. So saan manggagaling yung sunod na equation? So gaya ng ginagawa natin before, that will come from the relation of their deformation. Okay? So from this figure, so di ba initial position, final position. So therefore, ito, this one, ayan, so that will be the deformation of your, ano ba yung nasa gitna natin? So that is the deformation of the copper. Okay? And this portion, so alin lang ba yung aluminum natin? Diba ito lang? Ayan. So that will be the deformation of your aluminum. Okay, so knowing this, ano yung magiging equation natin? So the deformation of your copper is just equals sa deformation ni aluminum, deformation ni aluminum plus 0.005. Okay, so simplify lang natin ano ba yung given in terms of stress. So again, we all know that yung ating delta is just equals to PL all over AE. From where yung stress mo is just equals to P over A. So when you solve for delta, so delta will be just equals to stress multiplied by L all over E. Okay? So substitute lang natin dito. So our equation will be stress ni copper. So ano ba yung length ng copper rod natin? Nasaan nga si copper? Yun nasa gitna. So anong total height nito? So that will be 10.005 over E. So, ang E ni copper, so given naman dito, so that is 17 times 10 to the 6 psi. That is equals, so, sa aluminum, so stress ni aluminum, and then multiply, so ano lang ba yung length ni aluminum? So, that is just equals to 10. Over, so what is E of aluminum? So that is 10 times 10 to the 6 psi, and then plus 0.005. Okay, so again, yung ating stress, i-check natin siya using this equation number 2. So gaya ng ginawa natin before, sa mga naunang problem, ito kasi may binigay na allowable stresses. So again, hindi ibig sabihin sabay nilang marireach itong allowable stresses nila. So meron dyang isa at mauunang isa. So i-check natin, ano? Check. So sa tingin nyo, alin yung unang marireach yung kanyang allowable stress? Okay, so check natin. Try natin muna si copper. So say that yung stress ni copper is equals to sa allowable natin na 20 psi. Okay, so what will be the value of your stress of aluminum? So from that, substitute mo lang yung value ng 20 psi dito sa ating equation number 2. Okay? So idiretso na lang natin ha. So kaya na lang, gamitin nyo lang to, substitute yung 20 dito. What will be the value of stress ni aluminum? So, pindutin natin. So, stress ni copper, so 20 times 10.005 divided by 17 times 10 to the 6, then minus 0.005. So, gawin natin to na ano ha, 1,000. Okay, so times 10 times 10 to the 6 and then divided by 10. So the answer here is, so divide natin ng 1,000 to make it in KSI. Okay, so the answer for aluminum will be equals to 6.7706. 6.7706 KSI. So ano yung answer natin? Okay, so nagkataon tama agad yung ating na-assume. So that is less than 10 KSI. Therefore, this is okay. But, i-check na rin natin yung ano ha, yung paano naman kung si aluminum yung unang na-reach ng 10 KSI na allowable. So, check lang natin. Gusto ko lang makita na mali yung kay aluminum. So, say, so stress ni aluminum is equals to 10 KSI. So, what will be the value of the stress of copper? So, ganun lang din. Itong 10 KSI, substitute nyo dito. Okay? So, pindutin natin. So, we have 10 KSI. So, convert natin siya to PSI. So, times 1,000 o times 10 to the 3. So, times 10. And then, divided by 10 times 10 to the 6. Plus 0.005. And then, times 17 times 10 to the 6 divided by 10.005. And then, so that is in PSI, so divide mo ng 1,000. The answer is 25.4873 KSI. Okay, so as you can see, that is greater than 20 KSI. Therefore, this answer is not okay. So tama na ito yung ating nakuhang sagot. Okay, so that will be the actual stress during dun sa ating application ng P, yung pinapahanap. So when the copper reaches 20 KSI, si aluminum makakaramdam lang ng 6.7706, which is correct naman, no? Kasi kung i-analyze mo, mas mahaba yung copper. So therefore, mas marami siyang kaarganing load. Kasi do sa initial point, siya lahat yung nag-aarga ng P eh. Tama? Dito lang tumulong si aluminum nung bumaba siya ng 0.005 inches. Okay, so anong hinahanap? Yung allowable stress. So with this value of the stresses, yung 20 at saka itong 6, tsaka pa lang natin i-apply yung equation number 1 para mahanap natin yung maximum allowable load P to satisfy this condition. So consider equation 1. So ayun. So again, stress is just equals to P over A. So i-multiply lang natin ng area ito mga nakuha nating volume to. Okay? So we have 20. So una si copper. So we have 20 KSI multiply by the area of the copper. So copper, nasaan si copper? So that is 2. And then plus, so ito 6.7706 multiply by the aluminum na 3, and then equals to P max. So what will be the value of our maximum allowable load P? Pindutin lang ulit natin. So we have 20 times 2 and plus 6.7706 times 3. So the answer is 60.3118. Okay, so this is our answer. Okay guys, so that ends our discussion. So we will now proceed with the next type of deformation. So this time, papasok na tayo sa temperature o the thermal deformation. Okay, see you.